2 million years ago, our ancestors stood at a dead end. They couldn't get smarter. They couldn't think faster. Their brains were trapped by their own biology. Then one night, everything changed. A flame flickered in the darkness, and without realizing it, we began cooking our future. Ever noticed how much time other primates, like chimpanzees, spend just eating? We're talking hours and hours every single day, just chewing through tough, raw plants and meat. Now think about your own day. You probably spent, what, an hour or two eating? What's the big difference? It's one of the most fundamental things that makes us human. We cook. This simple act, applying heat to our food, didn't just make our meals tastier, it fundamentally rewired our biology and kickstarted the development of our civilization. It's the story of how a single innovation unlocked the potential of our species and made us who we are today. So, how did a simple campfire lead to skyscrapers and smartphones? Let's dive in. To understand the profound impact of cooking, we need to talk about energy. Every living creature operates on a strict energy budget. You only have so many calories to spend each day on things like moving, thinking, and just staying alive. For our early ancestors, this budget was tight. Raw food is incredibly tough to process. Think about trying to chew through raw, sinewy meat or fibrous, starchy tubers. Your body has to expend a massive amount of energy just to break it down and extract the nutrients. This is where a fascinating idea called the expensive tissue hypothesis comes in. The theory suggests there's a trade-off in the body between the size of the gut and the size of the brain. Both are expensive organs, demanding a lot of energy. You can't afford to have a huge energy-guzzling digestive system and a huge energy-guzzling brain at the same time. Early hominins with their raw food diet were stuck. They needed a large, powerful gut to do the hard work of digestion, which left very little energy for growing a bigger brain. They were in an evolutionary bottleneck. No matter how smart they might have been, their diet was holding them back, capping their cognitive potential. The math just didn't add up for a bigger brain to evolve. They needed a way to change the energy equation. Then somewhere around 2 million years ago, everything changed. Our ancestor, Homo erectus, made a discovery that would alter our destiny forever: fire. We don't know exactly how it happened. Maybe it was a lightning strike that set a tree ablaze and a curious individual dared to get close. Maybe they learned to control it, to keep it going. But what started as a source of warmth and protection from predators soon became the world's first kitchen. Imagine that first moment someone accidentally dropped a piece of meat or a root into the flames. When they pulled it out, it was transformed. It was softer, easier to chew, and smelled incredible. This was the cooking revolution. Cooking is essentially a form of pre-digestion. The heat breaks down tough collagen in meat and complex carbohydrates in plants, doing much of the digestive work before the food even enters our mouths. This means our bodies have to expend far less energy to get far more calories and nutrients. Suddenly, the energy budget looked completely different. A cooked meal provided a massive surplus of energy that was previously locked away in raw ingredients. It was like striking oil. This newfound energy surplus was the key that would unlock the evolutionary bottleneck and pave the way for the rise of the human brain. The biological consequences of this shift were dramatic and surprisingly fast. With cooking doing the heavy lifting of digestion, our bodies began to adapt. The expensive tissue hypothesis played out in reverse. Since we no longer needed a massive, powerful gut to grind down raw food, our digestive tracts started to shrink. Fossil evidence shows this happening over generations. Jaws became smaller, teeth became less robust. All that energy saved from maintaining a large gut was now free to be reallocated. And where did it go? straight to our heads. The human brain began to expand at an astonishing rate. This wasn't a slow, gradual change, it was an evolutionary explosion. The brain, remember, is the most energy-hungry organ we have, consuming about 20% of our daily calories even at rest. The nutrient-rich, easily digestible diet made possible by cooking was the high-octane fuel that our growing brains desperately needed. We went from having brains not much larger than chimpanzees to the massive, complex organs we have today. This rapid brain growth, or encephalization, is the single most defining feature of human evolution. Without the energy unlocked by cooking, it simply wouldn't have been possible. We literally cooked our way to bigger brains. But the impact of cooking went far beyond our biology. It reshaped our society from the ground up. Think about what a campfire represents. It's a central point, a place to gather. Before fire, our ancestors likely ate on the go, much like other primates, foraging and eating individually. But cooking required a hearth, a home base. This simple act of gathering around a fire to cook and share a meal was a radical social innovation. It created a focal point for the group, a time and place for daily interaction. It was around these ancient campfires that the foundations of human culture were laid. As individuals sat together waiting for food to cook, they had time. Time to communicate, to plan, to share stories. This daily ritual likely spurred the development of more complex language. Instead of simple grunts and gestures, we needed words to describe the day's hunt, to teach children, to resolve disputes. The campfire became the first living room, the first classroom, and the first town hall all in one. It fostered cooperation, strengthened social bonds, and created a shared sense of identity. It's where we began to transition from being just clever apes to becoming a truly cultural species. The warmth of the fire nurtured not just our bodies, but our burgeoning societies. So, when we look back at the grand story of human evolution, cooking isn't just a footnote, it's the main plot point. It's what separates us from every other animal on the planet. The simple act of applying heat to food triggered the cascade of changes that made us who we are today. It rewired our bodies, shrinking our guts and supercharging our brains, solving the critical energy problem that had held our ancestors back. This biological transformation gave us the cognitive hardware for everything that followed: complex thought, abstract reasoning, and creativity. At the same time, it transformed our social lives. Gathering around a fire to share a meal fostered community, sparked the development of language, and laid the groundwork for culture. Every meal we cook, every time we gather with friends and family around a dinner table, we are participating in a ritual that is millions of years old, a ritual that fundamentally defines our humanity. Cooking didn't just give us better food, it gave us bigger brains, complex societies, and ultimately, the world we live in today. It's arguably the most important invention in human history.